Imagine a sun that never sets, one that could provide constant, clean power to Earth 24/7, no matter if it's night or day, rain or shine. Well, that's not science fiction anymore. It's the very real goal of a groundbreaking Japanese project called Ohisama, and it's all about harvesting solar energy in space and beaming it wirelessly back down to us. Okay, let's get into it. So first off, you might be wondering, why go through all the trouble of putting solar panels in space? Well, think about it. Down here on Earth, our panels are totally at the mercy of the day-night cycle, cloudy weather, and they take up enormous amounts of land. But up in space, it's sunny all the time, 24/7, with zero atmosphere to block the rays. Now that is a game changer.
All right, so here's our game plan. We're going to explore this vision of a sun that never sets. We'll break down how this crazy space power tech actually works. Then we'll zoom in on Japan's pioneering project, get a sense of the global race that's heating up, and finally, we'll weigh the incredible promise against some very real problems.
The core idea here is, well, it's absolutely revolutionary. We're talking about a world with a practically limitless supply of clean electricity, a world that is completely free from the limits of weather or the time of day. This is the big dream that's pushing scientists to literally look to the stars for our power. Okay, so how in the world do you get that power from orbit all the way down to Earth? I mean, you obviously can't use a really, really long extension cord. This is where the science gets super fascinating. Let's break down how it's done.
It really all comes down to 4 key steps. So first, you've got these huge satellites up there with massive solar panels, just soaking up that constant, unfiltered sunlight. Next, and this is the clever part, that energy gets converted into safe, low-density microwaves. Then, they use a super focused beam to send those waves down to a very specific spot on the ground. And finally, a receiving station on Earth catches that beam and converts the microwaves right back into usable electricity for the grid. Simple, right?
And that final step on the ground is made possible by this brilliant piece of tech. It's called a rectenna. Yeah, you heard that right, rectenna. It's basically a mashup of a rectifying circuit and an antenna. And its whole job is to catch those incoming microwaves and turn them back into the electricity we can actually use.
Okay, so that's the science. But is anyone actually doing this for real? You bet. Let's turn to the experiment that's making this all happen. Japan's Ohisama project. This is where all that theory finally meets practice.
Now, it's really important to get this straight. Ohisama isn't going to be powering Tokyo anytime soon. It's what we call a proof of concept. Think of it as a small-scale test flight, designed purely to prove that, yes, beaming power from a satellite in orbit down to the ground is fundamentally possible.
So what does this first test actually look like? Well, for starters, the satellite itself is pretty compact. We're talking about a payload that weighs around 180 kilograms, or just about 400 pounds.
And to collect that solar energy, its panel array is only about 22 square feet. So just picture a small area rug in your home. We're kind of working on that scale for now. And all that equipment up there generates about 1 kilowatt of power. For context, that's just enough to run a small appliance, like a microwave oven. So yeah, those numbers seem pretty modest, I get it. But here's the crucial thing. They represent a monumental step forward. Successfully pulling this off, even at such a small scale, is an absolute giant leap for the entire concept of space-based solar power. And look, this project didn't just appear out of thin air. It's built on some incredible groundwork. I mean, Japanese scientists had already managed to transmit 10 kilowatts over half a kilometer on the ground. They've beamed power from a moving jet to a ground station. And get this, they developed microwave beam control with an accuracy of 1,000th of a degree. That's just insane precision. All of this begs a really big question, though. With technology this futuristic and this complex, why is it Japan, specifically, that's leading the charge? Why are they investing so much to make this a reality? So let's dig into that. What is it about Japan that makes it the perfect incubator for an idea like this? What are the unique pressures and motivations that are driving this incredible innovation?
Well, it really comes down to a few key challenges. First, Japan has very limited land available for huge, sprawling solar farms. Second, its infrastructure on the ground is always at risk from natural disasters like earthquakes and typhoons. And third, ever since the Fukushima event back in 2011, the entire nation has been laser-focused on finding safer, more secure sources of energy.
This really gets to a core part of the national mindset there. Japan has this amazing history of turning its limitations, whether it's land or resources, into the very things that drive incredible innovation. Space-based solar is just the latest and maybe greatest example of that spirit.
But let's be clear, Japan is not alone in this race. Not by a long shot. This has become a full-blown global competition. The US has its own projects in the works, China has announced some incredibly ambitious goals for its own space power program, and the European Space Agency is actively researching the whole concept too. Everybody sees this as a huge strategic asset for the future.
So finally, let's step back and take a good, hard look at the future. Because for all its incredible promise, space-based solar power is facing some absolutely enormous hurdles before it can become a reality for all of us. On the one hand, the potential upside is just immense. You've got continuous clean energy, the ability to beam power directly into disaster zones, and maybe even a truly global energy grid. But the problems are just as massive. The cost is staggering, which we'll get to. You also lose some energy in the conversion process, that's just physics. Then you have to worry about space debris crippling a multi-billion-dollar satellite. And finally, the sheer scale of the infrastructure you'd need on the ground is a huge challenge all by itself.
And let's not beat around the bush on the biggest problem of all, the cost. Right now, NASA estimates that building these systems in space could be 10 times more expensive than just building similar renewable energy projects down here on Earth. That is a massive, massive hurdle to clear.
But even with all those challenges, the vision is just too powerful to give up on. Remember, the ultimate goal here isn't a 1-kilowatt experiment. It's to build gigawatt-scale power stations in orbit, each one acting like a dedicated sun in the sky, capable of powering an entire city from space. And that really leaves us with the big question. As we search for sustainable ways to power our growing planet, will we find the answers we need right here on the ground, or will our future ultimately be powered from high above it?